Здравейте! Take a deep breath and welcome to this module. It's about air and especially about the quality of the air in urban areas and how it impacts people's health when its quality is poor. The module is also about how to abate together the negative effects of air pollution through the wise introduction of urban-specific measures and even through long-term transitions in the way we live in our cities, towns and other settlements. As you know, breathing is crucial for life, especially among aerobic creatures like us humans. So let's find out how to breathe more clean air where we live today and for tomorrow. I'm Agil Buruf and I'll try to help you find your own path through and beyond the smoke. Air quality is a cross-cutting issue and we cannot look at it without having in mind the sustainability concept. The concentric model of the power economy, society and environmental imperatives, as well as the centripetal and centrifugal tensions and conflicts between them, give us the framework for understanding the roots of the air pollution problems, the current development paths of the living socio-ecological system, and the branches of the future solutions both locally and globally. Furthermore, the resilience concept, which includes the notions of adaptation cycles and adaptation capacity, provides us with an idea of the internal capability envisaged socio-ecological systems to face the ever-changing internal and external conditions. Some of the major drivers for human-induced air pollution are the regional-specific configurations of production and consumption, as well as technologies involved in these two main groups of socio-economic activities. Some of the technologies include an array of industries of excavation, domestic heating, as well as mobility-related combustion and resuspension of particles on surfaces which do not have high absorptive capacity. There are numerous sources of emissions of substances harmful for the environment and for people's health. Some of the most commonly observed pollutants in cities are the sulfur dioxide, nitrogen dioxide, and the particulate matter, most often associated with industries, transport and heating with solid fuels. There are many other toxic pollutants from specific industries and activities, including the ones from household chemistry and those of natural origin in the form of dust and biological compounds like allergens and pollen. The varieties of pollutants from a cocktail of irritants which can harm our health under specific conditions in the environment and within our metabolism. The pressures from these sources of pollution are expressed by their emittance, circulation and transformation, distribution and dispersion, with the mediation role of ecosystems and our organisms. There is higher pressure at places with more intensive development, agricultural, industrial, urban and the specific mixture of all these in the varying regional contexts of land use and spatial development patterns. Certain types of developments are associated with some or more of the pollutants, depending also on the scale of examination. These sources can be configured more compactly or can be distributed more evenly across urban areas and regions. With the help of prevailing climatic conditions and the conditions of regulative services of the ecosystem, these pollutants can be filtered and diluted up to a certain degree and for a certain amount of time. When exceeding this absorption capacity of the local environment, the concentration of pollutants may stay for longer and they can harm the health and life of many people, directly or indirectly with long-term effects. The state of the environment in terms of atmospheric air pollution is measured and compared to thresholds, ceilings or emissions and alarming levels of pollution. Such are usually defined and actualized in legislative acts after negotiations between academia, governments, non-government organizations and businesses. Urban areas rarely comply fully with the limits and the level of measuring pollution has improved. It is still insufficient to reveal the burden at more specific spots. The exceeding at some places is constant, at others seasonal or sporadic, and there is also history and possible futures stemming from the development paths. Beyond measurements, health status data can reveal air pollution as a major or additional cause for death, long-term disabilities and short-term disease among certain groups living or occupied at polluted localities. Urban areas are characterized by high concentration of people, human activities, including industrial and other technology-dependent ones. Many of the technical systems and tools rely on energy, either in the form of fuels or electricity. Most of the energy systems today are dependent on fossil fuels, for instance coal and oil, although alternative and renewable sources are being introduced at different pace. Even though there are many technical standards, best available techniques, and additional technological requirements from country to country and from place to place, the cumulative effects from all of the sources in urban areas can be substantial. The exposure of humans to air pollutants is linked to the respiratory system but also to the cardiovascular, nervous, immune, reproductive and other body and mind systems, which can be affected. Air pollution is a risk factor behind many diseases. Many people with specific diseases are vulnerable to medium and high concentration of air pollutants. The external effects from human activities emitting air pollution can harm not only humans, but also most of the other forms of natural life in and around urban, industrial and intensive agricultural areas. The methods for estimation of the impacts from air pollution are related to the species of pollutants found in the relevant areas. Because the impacts from air pollution affect the state of the urban and natural environment, the public health, the regional and urban economy, and even the local and regional politics, the approach to their estimation has to be holistic. Trans and interdisciplinary applied science methods and techniques are needed for understanding air pollution, taking informed action. Some of the urban-oriented air pollution scientific and professional fields include urbanism, architecture, and civil engineering, among many other fields. The involvement of such specialists depends on the phases and resources for knowledge and action building, but also on the place-specific problems and solutions. The general strategic approach to the issue includes analysis and synthesis through the following phases in the governance cycle: state-of-the-art knowledge review, information exchange, data gathering, stakeholder communication, public participation, goal setting, programming and budgeting, modeling, simulation and design of measures, implementation, administration and enforcement frame, monitoring and evaluation, including ex-ante and post-evaluation. These phases are not strictly linear in the general chronology, and overlapping is necessary in order to synchronize and to build upon the learning by doing approach. Some of the instances which gather knowledge, methods and techniques from the various scientific fields and disciplines are related to 5 key professional activities, namely emission inventories, pollution measurement, species apportionment, dispersion modeling, and exposure simulation. The urbanism, architecture, and civil engineering domains can contribute a lot to the modeling and simulation, but also to the inventories and measurements of pollutants. Geographic settings and urban context are crucial for the quality of the air. The long episodes of calm and dry or foggy weather can lead to dangerous retention of pollutants. Enclosed valleys or slopes at the windless side of mountains can lead to frequent and long-lasting inversions in rain shadows. Furthermore, the heat island effect from compact or intensive urban development can worsen the ventilation of whole metropolitan regions and cities even in favorable climates. The specific geo and urban morphology determine the existence of more or less possibilities for ventilation at different parts of cities and urban areas, where lower-lying fluvial terraces which are tightly built up with continuous urban tissue usually experience very severe episodes of pollution concentration. The specific land use, availability of green and blue infrastructure, the construction patterns and streetscape add specific advantages or disadvantages to the exposure to emissions. Last but not least, the density of inhabitants and occupants becomes a key issue to epidemiology studies. There are no universal prescriptions to the air pollution problem, although the goal of achieving more favorable quality of the air is a basic human right as part of the favorable living environment right. There are many similarities among clusters of cities and urban areas, but the exploration of problems and solutions has to be localized in order to achieve long-lasting results. The responses to the exceeding of air pollution thresholds can include a spectrum of actions, starting from acquisition and distribution of reliable data and information, going through the integration of knowledge for production of meaningful plans and measures, and reaching the wise transition towards less harmful energy management, mobility planning, and urban design alternatives can all be part of the solutions. Some of these rely on local visions and actions, others need bottom-up and top-down efforts at regional and national scale. And certainly, relations at continental and global level can influence decision-making through agreements, international legislation and funding. The focus at the urban scale has to fall on integrated land use and mobility, the green and blue landscape urbanism, the bioclimatic architecture, and building biology-oriented engineering. The adaptive capacity of cities and urban areas to respond to the changing national policies, economic restructuring, social change and technology diffusion relies on citizens' awareness, advanced specialists, capable administrations and far-sighted politicians. All these groups can contribute to avoiding the threats and using the opportunities for more sustainable choices of their urban communities in terms of the air quality. The conscious shifts in the adaptive cycles from one phase to another can prevent harm on human health, and it can lead to higher quality of life for urban residents. Professionals can act in all directions, improving citizens' awareness, training themselves, informing authorities and convincing them about the short and long-term impact and the alternative responses. How would you act?